All right, I have officially started recording for YouTube, and I have 0 viewers, which makes this terrible and good all at the same time. I know there's a lot of field hockey girls gone though, so what I'm going to do is I'm just going to basically speed through this. I'm going to give you a problem, and then I'm going to start working it out. Now, when I'm done working it out, I'm going to hold up the answer, and I'm going to go through problems quickly. That way you can watch this faster. I would suggest probably just pausing while you work on problems. I think that'll go a lot easier for you. Let me first kind of remind you what's going to be on your test. You're going to have a section that's distributing and combining like terms. You are going to have then a short section of like 6 problems on factoring out the GCF, so we'll do some of that. Then you have all of your equation solves all lumped into one. So most of your answers will be x equals a number, but you will definitely have some that are identity or no solution. And literal equations are in there too, so ones where there are variables. Lots of extra variables in there, and you just have to solve for x. And then there is one word problem. So that's what your test looks like. I'll start with a distributing and combining like terms problem. And it looks like we have 2 viewers now, which is awesome. So it looks like a few people relate, just like me. So again, we'll keep this. I'll try to keep this as short as possible today, since we've got relatively few viewers. But my few viewers that are now here, if you've got questions, definitely let me know. So I won't zip through it quite as fast as I was going to now that I actually have 2 viewers as opposed to 0. So let's just start off with a pretty easy one. I'm going to give you 2 right off the bat, actually. Okay, and we'll just see how both of these go. So both of these are going to be distributing and combining like terms problems. Okay, so for both of these, distribute and combine like terms, our first problem is 5 minus 2 times parentheses 3x minus 1. And our second problem is going to be distributing twice here. 5 times 1 minus 3x minus 2 times 4 minus 3x. Okay, those are our 2 problems. So do the best that you can on both of these. And then I'll stall a little bit of time while you guys are working on these. Give you a little time to catch up. And then we'll go from there. So we're going to do 2 of those. I'm thinking we're going to do probably just, we'll do 2 factor out the GCF problems. Then we'll focus on, we'll do some equation solves. We'll do a fair amount of those. I mean, maybe 4. And I'll at least sneak one identity or no solution in there. And I'll throw at least one tough literal equation in there. I was pretty nice on your literal equations. I don't really think they're that bad. And then I will try making up a reasonable word problem, and we'll go from there. So hopefully you have completed the problem. I'll rewrite the first one down, give myself a little bit of space to do it this time. My first step is that I'm distributing -2. That is the key. You distribute -2. Okay? So after you distribute the -2, you should get -6x. And that subtraction of 1 should turn into, whoops, paper falling, plus 2. Okay, because -2 times the subtraction of 1 is the same thing as -2 times -1, so that's positive 2. Combine your like terms, you're going to do 5 plus 2, not 5 minus 2, because you take the symbol before the number. So it's positive 5 and positive 2. Those combine to 7, and we get 7 minus 6x, or -6x plus 7 would be just fine and dandy as well. Let's try another one. The other one, after you distribute, I'm just going to show the distributing step here to save a little bit of space. I get 5 minus 15x after distributing the 5. And again, you got to distribute a -2 here. So it should be minus 8 plus 6x. This is what you should get right after you distribute. 5 minus 15x minus 8 plus 6x. Combine your like terms. So we have 5 and -8. Those make -3. And we have -15 and 6x. That makes 9x. -9x, excuse me, because it was -15. So we should have -3 minus 9x. So there's your 2 answers for the first ones. we should have gotten 7 minus 6x and negative 3 minus 9x. Hopefully that was the straightforward section. Next section should be pretty straightforward too, factoring out the greatest common factor from a polynomial. So I'll give you 2 of those. I'm going to take a peek at your test while I do, just so I'm giving you stuff that's, you know, pretty similar. Let's go with 10xy plus 5xz plus 15yz. We're going to go with that for the first one, and I will hold both of these up. And for the second one, I'm going to go with 16xy squared plus 12x squared y. So you're going to be factoring out the GCF for both of these. Again, the first one is 10xy plus 5xz plus 15yz. And the second one is 16xy squared plus 12x squared y. Okay? Factor out the GCF for both of them. Okay, factor out the GCF. And yes, Brody, your answer of 7 minus 6x is great, but I don't need to see your answer specifically, okay? You can tell if you got it right or wrong from when I hold up the answers. And if you haven't seen the answer yet, you're pretty delayed. Okay? Okay. Yeah, Flynn, I don't need to see yours either. Don't need to type your answers in the chat window. If you got it right, that's awesome. I will give you a virtual high five. That was 2 of them. How lucky are you? Okay, so factoring out the GCF in both of these, I shouldn't need a whole lot of room. In the first one, the tricky part is there are actually no variables that are shared by all 3. Okay, there are no variables that are shared by all 3. So I'm going to factor out just a GCF of 5. That's all I'm going to do. And I get 2xy plus xz plus 3yz when I factor that out. So that's what I get when I factor out the GCF from the first one. Second one, I get, they both have, so 16 and 12 have a GCF of 4, okay? And they each have at least one x, so I can take that out. And they each have at least one y, so I can take that out. The squareds aren't going to help, though, because none of them have, they don't have at least 2 x's and they don't have at least 2 y's. Not each of them, anyway. Okay, so my GCF is 4xy. And then 4 times 4 is 16, so I'm going to put a 4 there and add an extra y. And then 4 times 3 is 12, so I'll put a 3 there and an extra x. So that's what you should get when you factor out GCFs for both of these. Whoops, I used Christmas colors here unintentionally. I have some former students back when I taught high school that would have really hated me for using Christmas colors. I always hated when I used red and green on the smartboard. I could use almost any other combination I wanted to, but red and green they didn't like because they were Christmas colors. And I reminded them that it's not Christmas every time I use them, so I don't know, a little weird. Okay, that's pretty much it for factor out the GCF. I mean, the big key is on your test, what's in red here is what your answer should look like. Okay, don't just tell me what the GCF is actually factored out. Okay. All right. Next, we will do some equation solves. Okay. Let me start with. Let's do Let's do 2 literal equations first. So let's do 4x plus 12y equals 8, and let's do x over yz equals y over z. Okay, so here's our 2 problems that I want you to try here. Solve for x in both of them. I could have you solve for anything I wanted, but let's just have you solve for x in both of these. Okay. We'll do 2 literal equations here, and then I've got a couple more interesting ones that I can show you. For the most part, I'm assuming at this point you can solve for x, even when there's some distributing and stuff involved, but we'll do some other stuff there. So hopefully you got these both written down right now. Okay. I'll start getting some other problems ready, but looking at this test, I mean, there's, knowing its identity, knowing it's no solution. Okay, so like if remember, if you subtract from both sides and your variables are completely gone, that means you've definitely got identity or no solution. So if you have like 5 and 5 left on both sides, 5 equals 5, that's identity. If you got 5 equals something other than 5 and there's no x's left, then it's no solution. Okay, so we'll try some of those different ones here, and I'll make up hopefully some good ones. We'll see how I do. Okay, let's see how we were doing on these. I've already made up one that we'll do coming up next. So we'll start off with 4x plus 12y equals 8. First thing you should do is subtract 12y from both sides. You get 4x equals 8 minus 12y. Should probably show you that. My bad. Then let's divide everything by 4. We get x equals 2 minus 3y. And some people ask the question, maybe what happens if the 8 wasn't an 8? What if it was a 7? Or what if the 12 was an 11? You could use decimals at that point, or you could just leave those numbers as fractions, okay? But if you can simplify, like you can 8 over 4 and 12 over 4, then you definitely should. In the second one, we are going to cross multiply and divide. So we're going to multiply y times yz and then divide by z. So this is what x equals before we simplify. X equals y times yz all over z. And then the z's can cancel, and y times y is y squared. So we get that x equals y squared. Boom goes the dynamite. That's about it for literal equations. I mean, I think I have one or two more than that in there, but they're very similar to one or the other of those. So, I mean, if you got those answers right, you know, you should be feeling pretty good. Okay. I do have one problem for you to start off with, and then I'll try to get another one written here. Try solving for x in this one. So let me read that to you, because that's not a little mistake like right there. That is actually a negative sign. So it's 5 times 1 minus 2x in parentheses equals negative 3 times parentheses 4x minus 1. Close the parentheses there and then add 2x. So solve for x in this one. Do the best you can. Just solve for x. And then I'll get another one ready while you guys are working on this one. Said on for a really long time there. I'm not really sure why. I was kind of trying to stall for time a little bit. Let's go with this. This will be a similar one to one that we did in the game in class. I don't remember if both your classes did a game or not, but yeah, they probably did. Let's be similar to that. Okay, so I've got a second one written for when you guys are done with this first one. I'm going to assume you are done with this first one by now. And we get 5 minus 10x equals 12x minus 3 plus 2x. This is what we get immediately after, it's a terrible x. This is what we get immediately after distributing. We should combine like terms on our right side, and we get 14x minus 3 and that's 5 minus 10x equals 14x minus 3. Whoops, there we go. All centered now. And we're up to 3 viewers. Woohoo! Okay, and now we should add 3, or we got to get, I'll get all my x's on the same side. I actually like positive x's. I don't really care what side they're on. So I'm going to add 10x to both sides. Okay. I made a mistake and I just realized it. I didn't distribute the negative. I didn't see my own negative sign in that problem. I'm going to have to fix that. Should be negative 12x and positive 3. I'm sure you guys are probably already have typed a message towards me. Sorry, fixed it. I didn't see my own negative when I looked back up at the problem, even though I read it out loud to you. Shame on me. So let's try combining our like terms again, now that I got my signs right. Good thing I caught it before the end. That would have caused an uproar with all three of you and the YouTube audience that'll be watching later. So when we combine like terms, we get negative 10x plus 3. I think we can see where this one is going now. It's going where I intended it to. Okay, so add 10x to both sides. I do like to make sure that my variables actually do cancel out. So I get 5 equals 3. And 5 equals 3 means no solution. Woo! Hooray! Sorry about that negative sign mix-up. That's what I get for screwing up writing my negative sign in the first place. But I fixed it before the end of the problem. This reminds me, like the biggest thing to be careful of on this test is actually just when you're solving, make sure you show your work and you're just very careful with it. Like a lot of people made the mistake of, you know, like in a situation where, I'm just thinking back to when honors took this one. I'm going to use a really simple example. Like in a situation like this, people would subtract 4 from both sides instead of adding 4. Okay, or they would do it with x's too. Like if there was a negative 4x over on this side too, they would try to get rid of that 4x and they would subtract it instead of adding it. That was a big mistake. Positive and negative signs kind of messing that up. Those little mistakes add up on this test. There's plenty of points, so I mean a few of those isn't going to kill you, but if you're making a lot of them, you know, I mean that's really a sign that your brain just isn't quite processing things correctly, or you're processing things too quickly and it's not going well. So just be really careful on your test tomorrow. Time really shouldn't be an issue. You'll have the if you're taking it tomorrow anyway, you'll have the full period in 70 minutes, and yeah, you'll have a little bit of homework for over the weekend, but you can take the full 70 minutes if you really want to. Time to me should not be an issue on these tests. It should be, did you do it right? Did you take your time? I'd rather have you take your time. But that said, most of you, it shouldn't take that long. Okay, let's do the green one on here now. So that is 3 times parentheses x minus 3 plus 9 equals 2 parentheses x minus 2 and plus 4. Woohoo! There we go, solve for x. I'll get my work down in solving for x here while you guys are working. And then I think we're about ready to head on to some word problem stuff. So this is going to be nice and short, which is great. And if we end up with questions on the word problem and we need to do a little more, that's fine. I'm not anticipating it because we did hardcore work with the word problem in class one of the past 2 days for sure. Okay, so I've got my work done for this problem. I'll give you guys a few extra seconds, you know, just to finish up your problem if you can, since we do have 3 viewers now. I don't know who our third viewer is. We've got the Brody and the Flynn here. It is probably not a field hockey player, but we do have a third viewer, so that's nice. Hello, third viewer. Welcome. If you have not been to a Twitter, or not a Twitter chat, a Ustream review in the past, you can see my Bulls stuff in the background. I like the Bulls. They're my favorite team. I don't like the Bucks so much, but I don't hate them. Anywho's, here we go. So I just get my fingers out of the way there. Distribute the 3, and I get 3x minus 9, still plus 9. On the other side, I get 2x minus 4 plus 4. When I combine my like terms, I get 3x equals 2x, and a lot of people so badly want to call this no solution or identity. It is really not, though. The way you'll know if it's no solution or identity, your x's would need to be exactly the same. You need a 2x and a 2x, or a 4x and a 4x, or a 5x and a 5x. Because these sides are going to change at different rates, which means they're going to match up at some point. Subtract 2x from both sides, and you get x equals 0. Okay? If you've got an issue with problems like this, where you get down to just x's and no numbers are left, a really easy kind of thing that you can do is like, 3 times blank equals 2 times blank, right? Because that's what that variable means. So if you can fill in the blank with something that makes it true, then that's your answer. Well, I can. The only thing that'll work is 0, but it does work for both numbers. Okay? Let's do a word problem, and then we'll throw in one more literal equation that's been requested. So I am more than happy to do that, and we will definitely do that. Let's do a word problem first. So I encourage you at this point to listen very carefully, because I am going to say a lot of words, but I'm going to write very little down. So what I hold up may not help you. So listening would be spectacular at this juncture. Okay, so we're going to do a problem involving me and my wife. So I'm going to write Mr. and Mrs. down here. Mr. Strains and Mrs. Strains. Okay, I found $20. I found $20. That's important. Write that down. I found $20. And I am going to use this to start saving up for something. I don't know what, but I'm going to start saving up for something. Something big. I don't know. New Bulls jersey. I'd like a Joakim Noah jersey. It probably costs like $80 or something like that, but maybe I'll use that. I am going to save $1 a day. Okay, I'm just going to take $1 out of my wallet every day, and I'm going to put it in a jar with that $20. And I'm going to keep saving it until I save up for what I want. So I'm saving $1 per day. My wife, on the other hand, she, we're just going to pretend it was just her birthday. It's not. It's not till November. But she, on the other hand, boy, she is very lucky. She found, she got a $100 check for her birthday. Okay. However, she has this habit where she likes to buy a Dr. Pepper and some Skittles every single day. She really doesn't. She really doesn't. That's not true. But we're going to pretend so anyway. I'd be the more likely person to do that. And she is going to spend $2 per day on those items. Okay, so like going to some expensive vending machines and spending $2 a day. So here's the information you have. I start with $20 and save $1 a day. She starts with $100 and spends $2 per day. Okay? What I want you to do first is I want you to write an expression that represents how much money each of us have left after a certain number of days. I also want you to make sure that when you use x in here, or whatever variable you use, you define that variable and tell me what x means. Because that's the first thing we do. Okay, so you're going to define a variable, then you're going to write 2 expressions. I'm going to go out on a limb and assume you've probably done that already. Mine is pretty easy. Mine is 20 plus 1x, or just 20 plus x would be great as well. And my wife's is 100 minus 2x, because she's starting with 100, and then we are subtracting 2x from that every single day. And then I got to tell you that x represents days. Luckily, we didn't have to do any fancy subtraction or anything like that in this one from days. Now I'm going to ask you to find 2 things. I'm going to ask you, as it turns out, just me, am saving up for a Joakim Noah jersey. And that jersey costs $75. I want to know when I will have $75. Yes, you could probably do that in your head, but that's okay. And the other thing I want to know is when will my wife and I have the same amount of money should we keep up these spending habits? Okay, so I want to know when I have $75. And I want to know when my wife and I have the same amount of money. 2 different questions you should be able to find using these expressions. Okay? And again, these should be pretty straightforward. Okay, I'm gonna kind of pause a little bit, and then I'm gonna start writing one more of the ratio type of problems. Okay, let's see if I can give you a little bit of a better one this time. I'm going to give you one that's a little more numerical based when I give you another problem where you're solving for x in a literal sense, okay, the literal equations. Okay, I'm going to show my work for these other problems now. So for the first one, I should do 20 plus x equals 75. I'm sure you guys didn't necessarily set up an equation, but just it's a good habit to get into. So all I'm going to do in that case is set my equation equal to 75, so 20 plus x equals 75. I don't need my wife's because I just wanted me. I subtract 20 for both sides, and I get x equals 55. I'm assuming we all got that one. Okay, now if I want to know when we have the same amount of money, this is actually not too bad a one either. Same is really just equal. So write my expression, 20 plus 1x. Write my wife's expression, 100 minus 2x, and put an equal sign in between them. So 20 plus 1x, you don't need to write the 1 and a little bit of a habit from what I wrote up here. Oops, up here. Now solve for x. So I'm going to add 2x, and I get 20 plus 3x equals 100. And I get 3x equals 80. And then when I divide by 3, what I find is that I don't get a whole number, right? I don't get a whole number. 80 is not divisible evenly by 3. Okay, so the question is then, what should I do with my answer? Okay, so do 80 divided by 3. You can use a calculator if you want. This is not one where you should probably leave this as a fraction. You shouldn't leave it as 80 thirds. Okay, but you get 26. 25 would be 75, so you get 26 and 26.6 repeating, I believe. You'll let me know, I'm sure, if I did that wrong. Okay. So the question is, what do you do with that information? We wanted to know when they're the same, and you got 26 and 2/3 days. Well, you have a couple different options. You can, if you assume that I am literally just at the end of the day putting $1 in the jar, and my wife is spending exactly $2 at the exact same time every day, you could take that answer and basically say you will never have the exact same amount of money because it would happen. It would have to happen in the middle of a day. That would be a fine thing to say. You could also just assume that maybe some of this is happening over time or whatever, and you could just leave your answer as it is and say 26 and 2/3 days. The key is, if you get a decimal like this, please show your work that gets you all the way here, that gets you to this point, but then just explain to me how you're planning on interpreting that answer. Like in this one, I would probably say that I don't think we ever meet. I don't think we ever have the same amount of money, and you can just say because the answer is 26 and 2/3, and since all of this is happening at once, I'm losing $1 at once and she's saving $2 at once, it would be fine to say they never meet. It would also be fine, I think, to leave it this way. It's open for interpretation. Safest way is probably just to leave your answer, but make sure you just show your work. Okay? I don't know that I gave you anything quite that tricky on the test. I think they met at whole numbers on the test, but you know, it's a cool thing to look at, and I know we've looked at it before, so it's a cool thing. Let's do one more. We'll do this. So let me read that to you because, gosh, I can't differentiate my 9s and my A's, and then when I put them in the same problem, it's really bad. There we go. I did a little better job there. I fixed it. So we're going to do x over 9a equals 1/3. X over 9a equals 1/3. So again, basically what you do with this is you figure out what you're solving for. Okay, so we're solving for x, so I just changed its color a little bit. And then what you do is you cross multiply. So like you have two options for it. You could cross multiply. You could cross multiply 3 and x, or you could cross multiply 1 and 9a. Well, you want to cross multiply 1 and 9a because x is what you're solving for. You don't want to do anything with that if you're solving for x. So you're going to cross multiply those two numbers, 9a and 1, and then you're going to divide by 3. You're going to divide by the only thing that's left that's not what you're solving for. Okay? So you're going to do 9a times 1 divided by 3, which is just 9a over 3. And you can simplify the 9 and the 3, because that means 9 times a divided by 3, so it's definitely okay to simplify the 9 and the 3, and your final answer should just be 3a. Okay? I think this has been a very good variety of problems. If you're watching this later on YouTube, which I'm sure many of you are, not the 3 viewers that I have now, but certainly many of you will be. If you're watching this on YouTube later and you had a question about something, you can feel free to just come talk to me in the morning if it's just one question. I'm sure I'll be able to answer that for you in the morning. You can try to shoot me an email tonight too, and I'm sure that'll help. But this is one of these things I feel like if you've been working hard all the way, I think you're going to be in good shape. Sloan made a study guide, and I did put that up there. It's just a lot of problems from either the book or from concept quizzes and places like that, but they're all in one place for you, which is just super convenient, okay? And that would be an easy thing to do. And if you feel like you had trouble with any of those, again, you could let me know that too. So I'm going to log off and post this to YouTube. If you're watching it on YouTube, you already know that. So hopefully this is helpful. And good luck on your test whenever you take it.